All right, everyone. Thank you for being here today. So let's get going. All right. So we all know about, depending on what the areas that you work on, right? Web development, database development, etc. We basically sometimes we work on dashboards and data integrations and so on, right? And we understand the purpose of dashboards, right? Dashboards are for the purpose to visualize data points and KPIs, right? Key performance indicators, which is what enables the business to understand how things are going, how is the business doing and so on, right? But some of these dashboards really depend on the human interaction, right? The user to be able to kind of understand what the dashboard is indicating and how to read it. And especially in areas, depending on the industry you work on, there are areas where you require quality monitors. And what that really means is kind of take a look at a particular dashboard that monitors a process. And if that process may be trending out of control, meaning what you expect out of the process is really not working because there is some kind of error going on in the process. And when I'm talking about process, I mean like a physical process, right? Where you measure telemetry information, like on a manufacturing line where you actually have robots that are building microchips and so on. So these robots are sending data points, streaming data points to these dashboards, and it's massive amounts of data. So a person is hard for a person to kind of monitor that. So we are talking about that kind of industry right now. The example for today's presentation is about that, but this is applicable to anything, to sales, to retail, and so on. Okay, so this is applicable to that. So welcome to today's presentation. My name is Oscar. I'm really glad to have you here today. So I'm a software engineer. I focus on data, AI technologies. I also have a book, Data Engineering Process Fundamentals. If you really want to learn more about data engineering, not from the perspective of learning how to use a tool, right? Not with the focus to how to use a particular tool, but to understand the process and the skills to enable you to follow a data engineering process with a lot of hands-on programming using Python, using SQL, using cloud engineering, and so on. If you want to learn more about me, you can scan the QR code that takes you to a hub where you have my repos, my contact information like LinkedIn and so on. So Ricardo, that's the opportunity to look at that and me on LinkedIn. So in today's presentation, we are looking at a process where we need to applications and we want to be able to update that using AI. So how do we do that, right? What is the purpose to do that? Let's first of all understand the challenge, right? So with a real-time feed, right? What that means is as the processes are running, right? So think about maybe a manufacturing line where there's this robots building out something, or even some machines that are just processing some material, right? There is always the concept of quality where you actually have the need to be able to monitor this information, right? So how do we do that, right? So usually the way this is managed is that we have a telemetry stream. And what that means is material is going through that manufacturing line. The robots are reading, measuring, and so on, whatever they are building, right? And they're taking some data points, measurements, and they're sending that to a backend engine. The backend engine is, if it's a data stream, is in real time. So in real time, it's coming in a split second, and you see tons of data coming in from different devices, from robots, and devices that are probably reading information. Typical device that sends a lot of telemetry is the Alexa devices you probably have at home. That's probably sending a lot of telemetry. back to Amazon to be able to understand the health of the device and what the device is sensing. So that is really the challenge, right? So for this kind of when you are building something, there's the concept of control limits. And what that really means is that when this process is reading all this information, there are limits, right? You expect the process to follow certain thresholds, right? And it's what's called upper and lower limits, right? If you start seeing readings below or above those limits, that's basically called out of control condition, right? So that means that there's something in the process that's failing and we need to adjust it. We need to correct it. We need to stop the line or so on, right? So just kind of keep that in mind. That's our focus for today. But the principles of what we're talking about and the approach is really is applicable to everything. Right. So in today's example, basically what we're looking at is we're looking at what's called SPC charts. And basically what this is indicating a live process that is sending telemetry information in real time. And we see some of the control limits boundaries that are the red lines that you see there. And what that means is any data point that comes in should be within those limits, right? If they start going beyond that, then we have a problem. And imagine you as a QA, as a quality engineer, and you're just kind of looking at this, right? And you have to be on top of this, and you start seeing trending conditions that are just basically drifting from what you expect. Well, that's a problem, right? So you have to react to it, and the reaction is that you have to do you have to look at it closer and kind of maybe sometimes stop the process because something is happening, right? So that is the challenge, right? All right. So what is the typical architecture for this? So let's review a little bit of the architecture to make this real-time integration happen, because it's key. It's important to sort of understand that in a real-time distributor system, there is also the opportunity to plug in AI agents to be able to help us out, right? So let's just kind of understand what's happening. So here, basically in this, and you can look at the GitHub repo, it basically documents how to set it up if you want to, and what technologies to use. So we start with basically a Redis cache. And if you're not familiar with that, that's just an in-memory cache enterprise level system. That what it does, it enables you to cache data. So if you're familiar maybe with MySQL, SQL Server, and so on, relational databases, they're high on I/O, right? So basically what that means, the reads and the writes to the database, they're kind of expensive and slow, so they're not very good at performing when it comes to a real-time system that sends tons of telemetry information at a split-second frequency. Okay, so we need something faster, right? And Redis cache, in-memory cache, any memory cache system can do that for you because everything is basically in memory. There isn't a kind of an I/O disk in process to slow it down, and there's no data contention and all those other problems that we have with a relational database system. So, and to kind of manage these massive amounts of data, I want to investigate, right? So the real-time analysis gives you what's happening now, right? What's happening within the last few seconds or last few minutes, but you probably need to investigate later on. So you need to have a data warehouse, data lake, some kind of relational database system for historical purposes, because you kind of need to go back and get the data and start doing trend analysis. To give you an example, if you start seeing that this week, for example, you can say, I went out of control. The system went out of control twice this week. You can kind of start going back a month ago and see what happened. Do you see changes progressively happen since last month? And you can kind of look at all that data and do analysis. So that's the purpose of the data warehouse and data lake when it comes to that. And then you have the engine, right? The engine that runs everything and orchestrates everything, which is basically your processing engine that's actually going to allow devices to connect to process data. It's going to connect to the Redis cache, to the database, to the data warehouse, and it's going to process the data in such a way that it enables us to consume the data from devices and broadcast the data to dashboards or other applications that are managing and monitoring the data, right? So that is the node controller is really the heart of everything. So with knowing that, then that gives you ideas of, okay, so if I have a system like this and I need to integrate AI into it, right? Maybe that is the best area to do it, right? So because everything is flowing through there, perhaps in there I can inject a smart process or a AI agent and feed that data to that. But we need to be careful too, because this is massive amounts of data, right? Split second frequency. So you're not gonna go and take every data point and feed it to the AI. It's just gonna cost you too much money, right? So you have to manage that. So there are strategies for that in data engineering with other systems like Kafka as well, and so on, that we manage the data that way. So just be mindful that for massive big data issues, data streaming issues like this, then you need to sort of window the data samples, create basically a snapshot with at a certain window of time, and process that data. So that's our strategy. So, and we'll take a look at how we do that. All right. So just from a very high level view of what we have on this repo, right? So the idea, the principles here is that we have IoT devices, right? Many of them that are deployed, and they have sensory data. They're capturing information, and they're sending all of that to our system, to our node controller, right? And basically, what it's doing is it enables our cluster to get that data, whether it's API or socket integration, right? And API just basically is our standard post request to a server to create a new record, and you're probably familiar with that. And the socket integration, WebSocket integration, is what enables us to do real-time bidirectional data. Okay, so if you're not too familiar with that type of technology, just keep in mind that everything that you basically get in real time, like a chat and you chatting and all that stuff, is a bidirectional channel that enables you to send data and send a chat and get a chat back and so on. So that's the kind of technology and communication channel that is being used here. So here we know that our controller basically is going to send the data to Redis and a relational data warehouse. And the way this works is that we need to kind of distribute the load, right? The data. So we actually keep our Redis with the cache with a certain amount of data that is important for the monitor services, for the dashboards and so on, in our databases for our massive amounts of data for analysis. So the cluster needs to balance that and understand and be smart about that. But knowing that happens there, that's when we can use, in this case, an AI engine and be able to build an agent and inject that agent into the process and send that data to the agent in a controlled way, so the agent can do analysis for us, right? And ultimately send this data to our dashboards. Okay. So I talked a little bit about this, the human in the loop. So the problem with this kind of systems is that a person becomes a bottleneck, right? It's really difficult to monitor all these data points, all these events, and react to them, right? So you have a cognitive overload where really you're gonna miss a lot of data points, a lot of patterns, because the data just keeps on coming so fast, right? So we need to be able to assist the person on this, that is managing this kind of work, and AI is a good partner to have for this. Alert fatigue is basically when you see a lot of violations and probably you're not really understanding what's happening in the process. You may not be able to act on time or completely ignore the violations. And the violations are the out of control conditions, right? When your project the process is trending out of control. So you have response latency, you can't react to it on time. And what that represents basically is the process keeps on running if you're manufacturing, right? And it's just running and burning out material that can be very expensive and that costs a lot of money, right? So what you got to do is react quickly so you stop wasting material. Okay. So how do we solve it? What is a good way to have to take a system that already exists and inject or use an AI agents? And what are the principles that guide this agent that can help us, right? We know the challenges, right? How can an agent help us? So the three principles, right, of an AI agent basically is perception, reasoning, and action. And what that basically just means, the ability to basically understand the data, right, and consume that data. So this is a good fit for an agent just because we do have that concept in our system, right? We have the concept of building sliding window of data to do analysis and be able to understand if a process is trending up or down, right? So the agent can help us do that. Secondly, the agent can basically reason, right? So if we feed the data with the correct information, just like training someone new, right? When you train someone new, you explain the process, you explain what you're looking for, you explain what are the actions that you need to do in case something's happening. So reasoning AI is really good at that, right? You can actually set up system prompts and actually provide it with user prompts and allow it to reason. And if you're not familiar with system and user prompts, we'll see a code example of that. But system prompts is basically the overall persona of that agent, right? So basically saying you are a QI engineer, QA engineer, and your job is to evaluate the following data points with this meaning and so on and so on. And the user prompt really is mostly to say, hey, I noticed these data points are saying this. Can you tell me more? Right, and that's the user prompt. It's more specific and geared towards a particular question. And then we have action, right? In action, the purpose of that is because for this environment, we need to be able to reason to what the data is doing, understand it, and take an action. And the action could be shut down the process, take a closer look at the process, and so on, right? So the agent can be integrated with other systems. A lot of these manufacturing processes that have robots have interfaces where we can actually integrate an action from an agent and send a shutdown signal, for example, right? And it will automatically shut down the process. So in this case, for our example, we can basically enable the agent to give us a description and analysis of what's going on, and we can follow that. So you can actually take a look at the repo that you see on the screen. I also added a link to the chat. Just copy that. And let's take a look at that. Let's take a look at how this works, right? So first of all, when you go to the repo, right? Let me see if I don't lose you. Let me know if you don't see the GitHub repo, but you should see it now. So basically, this is the GitHub repo, and it just basically documents what we're trying to do, right? I'm not gonna go into much detail now, but we're basically taking a look at this and integrating AI, right? If you want to set this up, you can just follow all the directions here, and you can see all the instruction on how this works, right? And if you want to take a look at the code, then we can drill into the code and talk about it, and so you have an understanding. So everything is in there. You have a client and you have a server. The server component is our hub that maintains all these communications with the cache, with the data warehouse, with the different socket connections, APIs, and so on. And client is really small client for a dashboard. So we'll take a look at the client really quick. And you have the instructions on how to load it and everything. Of course, I have the client already running, an instance of it, and we'll take a look at the code. But essentially, this is it, right? It's just really saying, I have these temperatures. I'm monitoring all this telemetry data, and I'm just showing the data, right? Simple dashboard. Not a lot behind it if you don't know how this works. But if you do understand what this works, this basically means that you have a control process where temperature and sound are within the control limits of the expected process. Everything looks good, right? So we're going to make this run now in real time, because right now this is just static, right? I just did the last lookup and said, hey, give me the last window of data, and it just presented that. So we're going to run a device basically that's going to enable us to simulate devices connecting in real time. So, and this is also on the server project, and we'll take a look at that. And basically this enables us to open a socket connection and immediately broadcast some of the last snapshot that was available. And then we can just kind of run it in real time. And what it will do basically is just processing data in real time, and it's broadcasting it to whoever is subscribed to the data feed. And the data feed subscriber is this application. So this application basically what it's doing now is just getting data points and basically it's plotting them, right? So it's getting events and it's plotting them, and it's, for what we can see right now, everything is within limits, right? Everything is floating fine, properly, and it seems to be okay. So what we have here also, if you notice a window here, it says agent analysis. What we're doing there is we're just waiting for an agent to give us feedback. And the agent feedback can be controlled based on settings, right? We can say, give me analysis every 10 data points, give me analysis every 20 data points. So this is kind of the sliding window concept, where we basically are saying, hey, monitor within this data window, monitor if everything is okay, right? Oh, as you noticed just now, an agent responded, right? The agent responded and is saying, hey, I noticed, let me see if I can increase this. I noticed the following, right? And it's telling us everything that's happening, right? I notice your data says, I notice the humidity is reading like this and the temperatures, and it's just basically saying there is no indication of any accelerating trends or drifts that will suggest a process going out of control. So there are no safety breaches detected. Everything is within the control limits. So this is giving us basically all the information that we need from this data. Imagine if you're just new to it, it gives you everything like that. So let me stop this. Right. So basically right now I just stopped the devices, right? So the real-time device is sending all this amounts of data into our process, and we're broadcasting this information. So but okay, so that looks okay. How do we build this? How do we manage to do this, right? All right, so let's see how we do that. Just going back here. So remember, you're going to have a server folder and a client folder. Server is everything for the server components, and client is used for the dashboard client application. All right, so let's take a look at this one really quick. All right. Let me make sure that you can see this. So I just switch into Visual Studio Code. Okay, if you see that, I'm going to try to blow this up a little bit so you can see it. Okay. So I see, if you notice on the GitHub repo, I indicated that there is a server folder and a client folder. You can see that here. When you go to the server, look for this server.js file. And it's just a Node.js server application. Of course, you can use Python, you can use C#, .NET to do this. But basically, looking at the principle of everything, right? What this is basically importing modules into the process, right? So it's a server application that imports modules, and those modules are the telemetry API module, the socket IO module, the database strategy module. And the database strategy is just really a design pattern to enable you to do this strategy to cache and write data to a data warehouse, right? So it gives you that balance to say, I'm going to take a look at my cache, and if I don't have it there, I'm going to add it to the cache, but also I'm going to fork it into my data warehouse. So because the application is reading off of the cache, and that's basically the main goal here, right? But you just follow this like a book, like reading a book, and just basically notice that that is what this component is going to be able to do. So we're using a what we call service broker pattern here, which is basically does this handshake of between cache, between SQL, and imagine not just SQL, but anything else, right? In the sense, it could be different databases, like it could be BigQuery one day, SQL Server the next, and so on, right? It gives you that flexibility, and is basically agnostic to the technology by using this. But this basically opens up that server component that's listening to telemetry data and is processing it and adding it. But how does it do that? Right. So basically, there are a lot of moving parts here, but I'm going to focus on the main areas, right? So the main areas here is basically the socket service. So in WebSocket, as I explained before, is what enables you to basically manage this bidirectional communication, right? You can look at the message broker strategy to be able to understand this balance of between cache and database. But let's take a look at the socket service. And basically, when we take a look at the socket service, what we want to take a look at this is, in addition to the principles of how it works, right, which is it's a lot more to talk about, but let's focus on basically it that enables a bidirectional communication by receiving events, right? So it's an event-driven system, right? And it enables other client applications to connect and subscribe to a particular event. So here you have events like message created, error, and so on, right? So here, what we're doing here is just basically connecting the server connection, right? And this is a distributed system, right? So we have a load balancer, and we're going to have all kinds of instances running. We're going to have 5, 10 node server applications running. So we need a centralized system, and that is our Redis cache. Redis cache is our centralized system that connects all these servers, and it broadcasts to all the servers. So that's how the bidirectional communication is going to go. And the server broadcasts through the sockets into all the dashboards and all the applications. Right. So what we do here is we kind of take a look at this line 56, and we're receiving through the socket, we're receiving a communication that says, I got a message. Let me go ahead and relay that message, right? So it says socket emit, and that's just relaying the message. And what that does, basically, it only sends the message, the data points of that telemetry message that came in, right? It doesn't do anything else but that. So, but that enables the client now to plot that data, right? The client gets it, sees that message, it adds another data point to the chart, it measures the KPIs, and so on, right? And that's all there is to it. It's a passive data analysis, a data dashboard, but there's no analysis to it at all. But we have another module here that we are incorporating, and we're actually asking an agent to do a watch, right? And we're passing the socket instance to it, and we're actually passing the data as well. So this enables now for us to inject an agent into a process that already exists, so you can consume the data and observe the information and do something about that. So we have the agent quality file here. And if you follow this, it's a simple implementation. we create what's called a quality engineer agent. So we have to give it the persona. We have to create the baseline of what it needs to do. So that's when we use what's called a system prompt, right? System prompt or instruction basically is telling it, hey, this is you. You are a quality engineer. You need to look at all these readings. You need to manage these control limits. And your directives are to do the following, right? If you see that there is a constant drift, take an action to shut down the system, which in our case is only just a message on the dashboard, but you can integrate that to other systems and manage the shutdown in real time and so on. So we give this system prompt, and this is fed to the agent. The agent caches this information as basically foundational information to be able to understand how it works. But then when we take a data sample, we send a particular prompt that says, hey, analyze this data sample. That is the user prompt, right? And there is something missing out of this integration that I'll talk about, and maybe one of you want to work on that project and add it. But the idea here is that as the agent watches, it creates a sliding window. And the sliding window just all really is taking a particular data set or snapshot at that specific point in time. Here we're just doing a small sliding window logic, right? And we're just kind of maintaining that window. And the idea is because we're going to be creating chunks of data, partitions of data, and we're going to keep feeding that to the agent every so. And so the agent has history for a particular window and be able to understand if things are trending bad or not, right? So here we just basically do the integration. We send the data to the agent. The agent basically goes and says, okay, I'm going to go ahead and analyze this data you're sending me. I'm going to send you my analysis back. And that's what we do here on line 78. We get a streaming result. So the agent is also streaming data back to us, right? It is sending us this data. And we process that data in real time, and then we're feeding it into our socket. On line 85, we're actually getting that analysis. We're basically creating the message, the payload, and we're emitting that to back on a event called AI chat. So this is a particular event the clients can listen to, capture that event, and understand that this is for the chat analysis, basically. Okay, so essentially here, this is our agent, and we're using the Gemini 2.5 Flash, and you can just basically use different models, different systems, and so on. The principle here is that we can inject an agent this way, an agent, AI agent into the process that exists, minimizing impact to the system, right? So the purpose here is not to have to redo everything, but to use what the current system and just upgrade it. So, but this is the server side. So what about the client side? On the client, basically, you want to go to the application here. And don't worry if you're not familiar with the technology here of Angular or React or what have you, just the principles, understand the approach, right? And we're going to look at a feature called telemetry, right? And this telemetry feature is really basically managing this telemetry communication, right? So if you had other features to do other kind of analysis, then you create another telemetry, another feature for that. But this one is specific for this. Okay, so, and you want to take a look at the socket telemetry service. And that implementation is really your client-side socket connection. That's what that is, right? So it understands that it's going to connect to a server component via sockets, and it's going to subscribe to a set of messages. And that's basically what we do here. And we're basically creating observers basically on telemetry data and analysis data, right? And we create two observers. And basically what that is going to help us do is, as the message comes in and via socket, we can push that data as events into the telemetry and analysis pipelines, and those are going to broadcast into the client application, as you saw with the charts and the AI analysis and so on. And if you can see here, we're subscribing, right? We're saying that we're subscribing to the unconnected, the uncreate, the unchat events. And those are the events we want to consume for this particular case. And we're going to connect to our server component and be able to manage now for example, the on-chat event. And this is specific to that AI analysis, and that's how that data comes in. And then when we receive an uncreated, and this is how we get the telemetry data, and we manage the storage to be able to understand the snapshot that we're working on the browser. Remember, this is the browser now. This is an Angular application, okay? And that's how we basically do that. But so this handles the pipeline between a message came in on the socket and the relay of the message into the data structure that enables the UI to observe that more data is coming in and be able to show us what the data. So for that, we look at the telemetry component, the HTML, the UI, and basically on the UI, you can see that we have the telemetry charts. Oh, and by the way, I forgot, we also have the chart components that you can take a look at that and how that is being built. And you look at the telemetry component that shows you how the charts are being built and so on, right? How that's data is being processed. But here we want to take a look at the AI agents actually getting the analysis data and getting that data asynchronously. So it's on real time, it's broadcasted onto the UI, and the UI can basically display that information. So that is basically how this is all connected. Of course, I'm oversimplified because of the time constraints, but basically this is how you can build all this out. And to follow this, just go ahead and continue to read the README file, and that gives you all the details on how basically this works and the purpose of it all, right? So this is huge. Even though we're using web technologies like Node, WebSockets, Angular applications, in fact, this is a huge data engineering implementation because it's really not only getting massive data in real time, it's actually doing data analysis as well. So it's really a big data engineering task. Okay. And if you want to learn more about data engineering, well, then I can just go ahead and reach out, contact me. I also have the book, and I'll show you something about the book. But the whole purpose here is that and answer questions in a bit. So just let me close this out. So basically, the summary is that we're able to change a passive monitor system, right, like we saw, into a smart monitor system by making small changes, not big changes, right? Doesn't mean that we have to wire everything in differently. Just kind of have to be very, very strategic and understand how the data flows and how the data is managed, and inject that smart module into your process so you can actually be able to, for example, upgrade that system into a passive system to a smart system. And things that you have to be very aware of is, for example, a good question is, why isn't it on client? And why don't you do it in the client? And the answer to that is because we want to centralize some of this stuff, right? So for example, this communication, you may have 10 different QA engineers managing different monitors, different processes, and so on. So you want to be able to centralize this in a way that you can broadcast to everybody, and you just subscribe to what you want. And if you just do it from the browser, then it becomes just a single chat, isolated chat, and that's not what you want. And you also don't want even though it makes sense to a lot of people, but it really does not, to be able to connect directly from a browser to basically a cloud service. Well, that's really, you have security issues and so on, concerns that you got to be aware of. So it's good to centralize. So let me just jump really quick. If you want to learn more about data engineering, just follow this QR code and also take a look at my book. I think you can download for free the digital copy or some of it of the digital copy. All right, so let's see. We are using Redis for caching, and we're facing an issue where if the Redis connection fails, keeps throwing continuous error, connection timeout. How we can handle this to prevent? Take a look at the server components that I have, because that can also happen to a socket connection, because it's kind of real-time subscription based, right? It's a pops up type architecture. So what you got to do is you got to fail over, right? So basically what that means, first of all, if you have a single Redis instance, that's a problem. You need to have redundancy. But if the connection fails, then you need to understand why it's failing. It could be that Redis is just basically completely disconnecting. You need to restart the Redis instance. The problem with that is you need to rehydrate Redis. If you go into the business of restarting the Redis instance, you need to rehydrate it. And in this example, that's what we do. If you look at the server component, we restart the service, we rehydrate Redis, and we have a baseline to start with. But if it keeps throwing continuous error, like connection timeouts, it's really, there's either your network latency or your Redis service is for some reason not performing. So you have to, but you need to fail over, meaning retry, reconnect, and see what's going on in the server logs. I know that's not too much of a help, but that's really how you go and analyze this on a distributed system. Yeah. So am I using ADK and ADK or any other framework? Definitely, you can use many other frameworks depending on what you need. For this instance, no, I did not use the ADK. I went straight native web with some of the libraries to be able to call APIs and connect to the Vertex AI system. But you have, for example, you have the ADK, which is also Google Agent framework. And other frameworks out there that are very good, and they actually what they help you with is to manage context, and what that means is really manage to keep up memory, right? To understand what's been happening, so they understand, they kind of keep that memory, and then it helps the agent have context over time, right? In our case, we manage that using a sliding window for the data. So the agent knows, okay, I have a system prompt, I have sliding window to analyze, and I have a user prompt to give you an immediate answer. All right, guys, okay, we made it right on time. If no more questions, I want to thank you. Please take a look at the repo. Please start the repo. GitHub, you can give it a start, and what that does, it helps you get notifications on updates and so on. Poluro, thank you for your message. Also, just kind of take a look at some of this data engineering stuff. It's all together, right? If you understand these principles, if you sort of understand this, you understand how data flows, how to do things in real time. You can incorporate AI to a lot of things to make web applications smart, data processes smart, and so on. Just gotta understand and be strategic about it, right? Don't just remember, cost efficiency is huge here. If you try to plug in AI for every data point, you're gonna be paying scary amounts of money. Okay. Everybody, thank you, Ruben. Thank you, everyone. Listen, follow me, please. Connect LinkedIn if you want, GitHub, a YouTube channel. We're broadcasting to the global AI community as well. You can join that, and we're broadcasting this to them as well. So everybody, thank you for being here today. Have a great day, and follow for our next presentation. Join that GitHub channel as well. Okay. All right. Just reach me on LinkedIn, Twitter, and we'll talk. Thank you.